Hi guys! How do we solve a differential equation that has this form? Now it is very evident that this function has a differential equation of the form m xy dx plus n xy dy equal to 0. Now from the looks of it, this cannot be solved by merely separation of variables nor homogeneous substitution. It seems that the fitting solution is through exact equations. So let's test this for exactness first. Okay? So by test for exactness, we seek to satisfy the partial derivative of m with respect to y equals partial derivative of n with respect to x. So let's go ahead and do that. Let's take the partial derivative of m with respect to y. That is, taking the derivative with respect to y of our m. In this case, it's this function. So we have x plus 3x cubed sine y. Okay. So taking the derivative with respect to y means that we're going to treat all other variables as constants. In this case, we will treat x as a constant. The derivative of a constant is 0, right? Now, how about this function? Now, we treat again 3x cubed as a constant and differentiate sine y. Still remember, cos u is, sine u du is cos u. The derivative of sine u is cos u. So, copying 3x cubed, we have cosine y. Alright. Let's now go to the next component, which is taking the partial derivative of n with respect to x, which is simply taking the derivative with respect to x of our n component, which is this one, x to the fourth cosine y. So x raised to 4 cosine y will give us the derivative of x raised to 4 is 4x cubed and then cosine y. Kasi we treat y again as constant. Now, from the looks of it, no, this too clearly, no, does not satisfy our test for exactness. So what do we do now with this kind of situation? Hi guys, and welcome to Differential Equations. In this lesson, we will be discussing how to solve non-exact equations. But first, our gospel thought. James 1:3 says, knowing that the testing of your faith produces endurance. If we're honest, most of us would like to solve or to avoid tests and trials in life. No one likes going through hard times. However, this Bible verse shows us something really great about the tests of life. It tells us that those tests produce endurance in our lives. Many times, athletes will undergo endurance training to help them become better in the sport they play. They train their bodies and their minds to withstand for long periods of time. This produces results like overall feeling better and having more energy. In the same way, we can grow in endurance training spiritually too. Each difficulty in our life gives us another chance to trust in God, and each test can help make us better. If we let them, the tests and trials in life can be a way for us to learn to trust God in new ways and to learn and grow in endurance. So the next time you're faced with a test in life, you can be encouraged by what this Bible verse says. Realize that even though the trials can be hard, they're producing character in your life. And if you let them, these trials can bring you to rely more fully on God. And as Lasallians, let us pray. I will continue, O my God, to do all my actions for the love of Thee. Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, the Son, and of the Holy Spirit. Amen. So going back to our situation earlier, what if out of curiosity, we multiply x raised to negative 1 to the whole function, to the whole fxy? In other words, to this whole equation. What if we multiply x raised to negative 1 to this function? So let's try and do that. What if, just out of curiosity, what if we multiply x raised to negative 1 to x plus 3x cubed sine y dy plus x raised to 4 cosine y dy equals 0. Multiplying to the whole equation. We're going to get, 1 plus 3x squared sine y dy plus x cubed cosine y dy equals 0. Now, we'll notice that we can identify here m, which is mxy, 1 plus 3x squared sine y. And you can also identify nxy to be x cubed cosine y, correct? Now, if we try and test this for exactness, by TFE, and that is satisfying the partial derivative with respect to m, or rather partial derivative of m with respect to y. That is taking the derivative with respect to y of the given function 1 plus 3x squared sine y. This will result to derivative of a constant is 0 plus derivative of sine y is, cosine y, correct? So that would be 3x squared cosine y. How about the partial derivative with respect to n? So taking the partial derivative of n with respect to x is actually taking the derivative with respect to x of the function x cubed cosine y. This will result to actually 3x squared cosine y. We did not differentiate cosine y because the variable for cosine, or the angle for cosine, is y, which is not the derivative we're trying to differentiate, right? Or the variable, or the variable we're trying to differentiate to. So from the looks of it, what can we notice about this two? Our partial derivative of m with respect to y and our partial derivative of n with respect to x. We can notice that they are now equal. Wow! Magic! So what is x raised to negative 1 here? What is this magic item or magic function here that made our whole function exact? Okay? So x raised to negative 1 is what we call an integrating factor. Okay? An integrating factor. So formally speaking, this integrating factor, or if the equation mxy dx plus nxy dy is equal to 0, that differential form is not exact, if that equation is not exact, but the equation mu xy mxy dx plus mu xy nxy dy, notice what we multiply there, mu, which results from multiplying this equation above, by a function mu xy is exact, then what do we call mu xy here? We call this an integrating factor of that function, mxy dx plus nxy dy. Now, konting kaalaman. Alam nyo ba that a general theory of integrating factors was developed by Alexis Clairaut in 1739? Leonhard Euler also studied classes of equations that could be solved using specific integrating factors. Ngayon, alam nyo na. Okay. Now, this integrating factor is guaranteed to exist if the given differential equation actually has a solution. No? Now, let's take another example. In this example, we're asked to prove that mu xy is equal to xy squared, which is our integrating factor for the given function of 2y minus 6x dx plus 3x minus 4x squared y raised to negative 1 dy is equal to 0. So let's go ahead and try and do that. So let's do that. Let's multiply. Let's call our new function f new. F new solution. Let's call our function f new xy, and that is the one multiplied by our integrating factor mu xy by our original function fxy. That is, we multiply x y squared, the integrating factor, to the whole 2y minus 6x dx plus 3x minus 4x squared y raised to negative 1 dy equals to 0. Yan. So, multiplying and distributing, we're gonna get 2x y cubed minus 6x squared y squared dx plus 3x squared y squared minus 4x cubed y dy equals 0. Okay. Now, we can already identify that m new xy here is 2x y cubed minus 6x squared y squared, and that the new n is 3x squared y squared minus 4x cubed y. Now, we check for exactness by doing test for exactness, actually. So that is by taking the partial derivative of m, with respect to y, and taking the partial derivative of n with respect to x. So let's go ahead and do that. Okay. So partial derivative of m with respect to y is actually the derivative with respect to y of our m, which is yung m new natin. M new and new. So the derivative with respect to y of 2x y cubed minus 6x squared y squared is actually equal to what? differentiating with respect to y, no, will make x a constant. So we'll copy 2x, and derivative of y cubed is 3y squared. So we'll have 6xy squared minus, again, differentiating with respect to y, we're going to have 12x squared y. Now, how about yung ating n? Taking the derivative with respect to x of our new n will give us 3x squared, or 3x squared y squared minus 4x cubed y is our n, will give us, differentiating with respect to x and treating y as a constant, will give us 6x y squared minus 12x squared y. Interestingly, they are now both the same. They are exact. So that's our conclusion. That this new equation is exact. Now, since this is exact, we can go ahead and solve this, through our exact method. And what is that? I'll be using method 2, which is the integral of mxy dy we can actually proceed and solve this exact equation by exact method 2, taking the integral of m x y dx and the integral of n x y dy, and then combining them later, merging them, we're gonna get a solution in the form of f of xy equals c. So let's first integrate this. So integrating with respect to x, our m, which is our new m, is 2x y cubed minus 6x squared y squared dx. And our n new is 3x squared y squared minus 4x cubed y dy. All right, so integrating, we're gonna get the integral of 2x y cubed with respect to dx, so we can factor out 2y cubed and leave x with dx minus 6y squared x squared dx. This will result to x squared y cubed minus 2x cubed y squared. Yan. How about this one? So integrating, we can factor out 3x squared. We have y squared dy minus factoring out 4x cubed, we have y dy. So we're gonna get x squared y cubed minus 2x cubed y squared. Yan. Now that we have both of our m and our n, we move on to our next step. So we can actually call this as step 1 or step C. Still recall, this is step D. And now step E is to merge C and D. Yan. And by merging, we're gonna get f of f new no? Or f nu xy. Without repeating, of course, we would have x squared y cubed, which is yung both expression we have on both n and y, minus, actually both pala, no? 2x cubed y squared. Yan. So this. And so forming our general solution, we can actually have step F, and that is form general solution, and that is F nu xy equal to C. Yan. So we have x squared y cubed minus 2x cubed y squared equals to C. Yeah. And that, ladies and gentlemen, is our solution for the non-exact equation. Now, the next question you might ask perhaps is, how do we find an integrating factor? No? How do we find an integrating factor? If mu x of y or mu xy is an integrating factor of the differential form m xy dx plus n xy dy is equal to 0 with continuous first partial derivatives, then testing, no? Then testing this equation for exactness, we must have the partial derivative with respect to y of mu xy mxy is equal to partial derivative of x mu xy nxy. So anong ginawa natin dito? If we want to find the integrating factor, no, it must of course need to pass yung ating test for exactness. And how do we do that? Of course, by multiplying yung ating integrating factor mu xy to the whole equation, no? And then testing for exactness of the two. We're gonna produce a function of taking the same equation and differentiating these two factors inside, no? By use of product rule, this reduces the equation to m partial derivative of mu with respect to y minus n partial derivative of mu with respect to x equals partial derivative of n with respect to x minus partial derivative of m with respect to y multiplied by mu. Now you might ask, no, saan galing yan? Saan galing yung sagot na yan? Actually, differentiate mo lang ito, no? And by use of product rule, kumbaga, this becomes partial derivative of mu with respect to y. And then, yung differentiate natin is yung first term, and then copying the second m plus. Yung second term naman i-differentiate, so copy natin si mu, partial derivative of m with respect to y. Yan. And then equals, differentiating these two again, yung first term muna, partial derivative of mu with respect to x naman, copying the second n plus, no? Copying yung first term mu and then differentiating the second term with respect to x. Yan. Now, if we take this whole part na ito, no? If we take this part, yung may mu, and transpose it here sa kabila, no? Magkakaroon tayo ng negative this part. Ito yun. Yan. Okay? And then, of course, if we transpose this part to the other side, eto yan. Yan. Eto yan. So yun lang yun. We arranged it such that yung partial derivative of mu is on the one side and then the rest are on the other side. Now, in this partial differential equation, we are not yet prepared to solve this, no? And thus, solving this would be difficult kasi PDE na to eh. Hindi naman sakop ng course natin yun. What we can do is to make simplifications. So, first simplification, let's call it case 1. Suppose the differential form mxy dx plus nxy dy is equal to 0 has an integrating factor that depends only on x. In other words, we will let mu be dependent on x, and that is mu x. Okay? So in this case, yung ating equation kanina, PDE form natin, partial differential equation, we'll have a mu of x, and mu of x. Yan. So yung mu doon natin equal to mu of x. What happens to that? It actually reduces this equation to a separable form. Bakit? Kasi if we try and differentiate this function, this first term, we differentiate this function with respect to y. Pag nag-differentiate tayo with respect to y, how do we treat yung other variable natin or variables natin? We treat them as constant, right? So in this case, Cx is considered as a constant. And if we differentiate a constant, it results to 0. So this becomes 0. Yon. Now, simplifying this whole equation here, if we multiply this whole equation with 1 over n, or 1 over negative n, para ma-eliminate to. See, negative n here. Malipat siya sa kabila. We're actually going to get the partial derivative of mu with respect to x equals the partial derivative of n with respect to x minus partial derivative of m with respect to y all over negative n. Ito yun. Multiplied by mu. Now, further simplifying, if we expand this denominator natin, at itaas natin yung negative papunta rito sa ating numerator, what will happen will actually be yung m natin this m will be positive and this n will be negative. So, interchanging lang yung position, we're gonna get partial derivative of m with respect to y minus partial derivative of n with respect to x all over positive n na and then multiplied to mu. Yan. This is that equation. Yan. Doon siya nanggaling. So, sinimplify lamang. Now, as you may notice, ito nga, it has been reduced to a separable equation. Why? Because this d mu over dx, this dx rather, can be multiplied to the other side. This dx here can be multiplied to the other side. And this mu here can be divided to the whole equation and be placed on the left-hand side of the equation, making it, separable. So, moving along, we have the same equation kanina, kinopya natin, d mu over dx equals this function here. Now, transposing, multiplying the whole equation by dx over mu, dx over mu effectively cancels dx and cancels mu here. This results to d mu over mu equals partial derivative of m with respect to y minus partial derivative of n with respect to x over n dx. Now, if we integrate both sides, this will result to du over u is ln u. And then, of course, the integral of this whole function. Now, we can cancel ln by raising the whole equation to e. So we're left with mu of x equals the exponential of the integral of epsilon of x dx, where epsilon is this equation. Same lang yan, no? Represent lang natin siya as epsilon of x. So mu of x is our integrating factor. Yun yung hinahanap natin to make a non-exact exact. And we can solve for that integrating factor by solving for the exponential of the integral of the epsilon of x dx. So that is case 1. Now, similarly, we have case 2, no? If the differential form mxy dx plus nxy dy is equal to 0 has an integrating factor that depends naman on y. In other words, the integrating factor mu is equal to mu of y. In this case, yung ating PDE kanina, partial differential equation, having this form, can now be reduced to a separable equation. How? Because we know that the derivative with respect to x naman, this becomes mu of y kasi, right? Mu of y, and mu of y. We know that the derivative with respect to x, no, will treat all other variables as constant. In this case, that is y. So, the derivative of a constant is 0. Yeah. In other words, this becomes simply partial derivative of mu with respect to y, m equals partial derivative of n with respect to x minus partial derivative of m with respect to y. Actually, dividing m will give us both sides, no? Yan. So, eto yan. Of course, mu. Nakalimutan ko. Yan, ito yan. Okay. So, this reduces the PDE to a separable equation. In a similar fashion, what we did earlier, no, sa case 1, we can multiply dy over mu on both sides, of course, to eliminate dy here and to eliminate mu here, so that it could be transformed, or rather transposed, moved, rearranged to their respective variables, no, respective variables. In this case, d mu over mu, and then dy on this right-hand side. Integrating both sides will give us ln u, the integral of partial derivative of n with respect to x minus partial derivative of m with respect to y over m. Okay? Now, of course, to eliminate ln, we need to raise this, the whole equation, to e. And this will give us mu of y equals the exponential of the integral of psi y dy, where psi here is also this one. Just for the sake of representation and simplicity, no? We represent it as psi y. Okay. So, in summary, no? If a condition, let's call epsilon of x is continuous. Epsilon of x having this function, of course, partial derivative of m with respect to y minus partial derivative of n with respect to x divided by n, no? The n function or the n component of the mxy plus nxy differential form, no? Is continuous and depends only on x, then it will have an integrating factor of mu of x e to the integral of epsilon of x dx for that differential form. So that's case 1. Epsilon of x, no? Case 1, dependent on x. Case 2, dependent on y. If a condition, let's call psi of y, is equivalent to the function here on the right-hand side of the equation, that is partial derivative of n with respect to x minus partial derivative of m with respect to y, divided by m, is continuous and depends only on y, then mu of y is equal to the exponential of the integral of psi y dy. Okay? That is the integrating factor, dependent only on y. Alright. Now, to summarize, here are my recommended steps to finding the integrating factors. First, of course, we need to identify what is yung ating m component and n component. Next is we test for exactness. No? Now, if it is not exact, we need to find an integrating factor to make it exact. And how do we do that? We first consider epsilon of x and psi of y. No? If epsilon of x is a function of just x, then an integrating factor is given by mu of x equals e raised to the integral of epsilon of x dx. Now, kung if psi y is a function of just y, then an integrating factor is given by mu of y e raised to the integral of psi y dy. Alright. So to better appreciate this, let's take a look at some more problems. So we have example number 3, 2x squared plus y dx plus x squared y minus x dy equals 0. So solution. Okay. So step 1, of course, is to identify. Step 1 is to identify m xy and n xy. So from this form, we can clearly identify that m is 2x squared plus y, and that n is x squared y minus x. The next step, of course, is to test for exactness. And that is to satisfy partial derivative of m with respect to y equals partial derivative of n with respect to x. So taking the partial derivative of m with respect to y, this will give us the derivative with respect to y of 2x squared plus y. This is actually equivalent to 0 plus 1. Okay. Now, taking the partial derivative of n with respect to x will give us the derivative with respect to x of x squared y minus x equals 2x y minus 1. Now, what can we say about these two functions here? That they are not exact. So what then should we do next? Yan. What we should do next is to find yung ating integrating factor. And how do we find the integrating factor? First, case 1. We use case 1, and that is epsilon of x equals the partial derivative of m with respect to y minus partial derivative of n with respect to x all over n. Now, if this gives us an expression that is dependent only on x, then mu of x is our mu of x equals e to the integral of epsilon of x dx is our integrating factor. Yan. So let's try and do it. So we have epsilon of x. We have epsilon of x equals our partial derivative of m with respect to y is actually the one that we have already gotten here. Ito yun, no? So 2x squared plus y. And yung ating partial derivative, sorry, ito pala sa baba. 1 is our partial derivative of m, and then 2xy minus 1 is our partial derivative of n. And of course, yung n natin here is from our n component, x squared y minus x. So pag samasamahin lamang ang mga sangkap sa ating pagsosolve, at tayo magkakaroon ng 1 minus 2xy minus 1 all over yung n natin, which is x squared y minus x. Ayan. Now, the goal here is to find and to simplify this equation to see if it is an equation that is solely dependent on x. In other words, walang ibang kahalong variable, dapat x lang siya. Yun yung aim natin na mapalabas. Kung hindi natin siya mapalabas, edi we'll have to try the case 2, which is psi of y. Okay? So, that is the goal here. First, to try and see if we can simplify this and eliminate yung y. Kung hindi tayo mag-arrive on an equation or on a function that is fully dependent on x only, then we will move to case 2. Okay? So, let's try and simplify this, no? We have 1 minus 2xy plus 1 all over x squared y minus x. We can add 1 here, and we're gonna get 2 minus 2xy all over x squared y minus x. Okay? You can further expand this to factor out 2, and we'll have 1 minus xy all over. We can factor out x, and we'll have xy minus 1. Itong dalawa, they seem to be similar. What if I factor out negative 1 sa numerator? What will happen kaya? So if I factor out negative 1, I will get negative 2, and then xy minus 1, which is surprisingly similar also to the denominator, making it cancelled. Yan. And so we're left with epsilon of x being equal to negative 2 over x. Now, is this an expression that is solely dependent on x? It is. In other words, since it has met and satisfied the condition, then we can be assured that the solution, or rather the integrating factor for this is, let's move this out to give space, mu of x is equal to e raised to the integral of epsilon of x dx, wherein epsilon is, of course, e raised to the integral of negative 2 over x dx. We can factor out negative 2 and have dx over x. And we know this as negative 2 ln x e raised to, no? By properties of logarithm, this will become e raised to ln, or x raised to negative 2. And so, since the natural logarithm is raised to an e, we have mu of x equals x raised to negative 2. So, yon yung ating integrating factor. Okay? But we're not done yet kasi we're asked to solve for the DE, meaning to find a solution. Now, since this is a non-exact equation, and now we have found yung ating integrating factor, we can proceed to multiplying it to our new or to our old f of x, fxy. So the next step, this is actually step C. No? Tama ba? This is step C. Yeah, this is step C. Now, step D. Step D. Step D is of course, f nu, no? xy equals multiplying that integrating factor to the whole fxy. So in other words, this becomes yung ating integrating factor, x raised to negative 2, no? Multiplied to the whole equation, which is 2x squared plus y dx plus x squared y minus x dy equals 0. Yan. So magkakaroon tayo ng 2 plus x raised to negative 2y dx plus y minus x raised to negative 1 dy equals 0. Tama? Yan. So we can identify our m nu and n nu here. So this is our f nu. And we can simply by looking at it, no? Yung ating m nu is 2 plus x raised to negative 2y. Whereas our m nu is actually equal to y minus x raised to negative 1. Yan. Now, ano kahalagahan yan? Ano? Mahalaga yan kasi when we do our next step, which is, of course, testing na, no? If this is exact really by means of test for exactness, which is satisfying the partial derivative of m with respect to y equal to partial derivative of n with respect to x. This will give us, no, so taking the partial derivative of m with respect to y is actually taking the derivative with respect to y of 2, yung ating new, 2 plus x raised to negative 2 y. And taking the partial derivative of n with respect to x gives the derivative with respect to x of y minus x raised to negative 1. Yan. So, let's take a look. So, solving this will give us 0 plus x raised to negative 2. And then this will be 0 minus negative 1 x raised to negative 2, right? Or, of course, 0 plus x raised to negative 2. Since yung partial derivative with respect to m, or rather partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, our conclusion is that this is now exact. And this has been made exact because of our integrating factor. We can now proceed to solving this by means of exact equation. So by exact method 2, we're gonna get step F. No. Integrating m of xy dx equals, and then of course, the next step would be integrating n xy dy. Yan. Will give us the integral of m, yung m nyo natin, which is 2 plus x raised to negative 2 dx, no, will give 2x plus derivative ng, integral ng x raised to negative 2 will actually give us, may y pala to. Yun. Puti na lang. Nakita natin. Yan. So, y will be equal to x raised to negative 1 over negative 1. Yan. In other words, we have 2x minus x raised to negative 1. Oops. 2x minus x raised to negative 1, no, times y. Yan. How about yung ating n part? We're going to have the integral of y minus x raised to negative 1 dy. So this will become the integral of y dy. Oops. Y dy minus x raised to negative 1 integral of dy. So we have y squared over 2 minus x raised to negative 1 y. Ayan. So we can call this equation C. Nalala pa? And we can call this equation D. And so, merging the two, no? Merge C and D. We're going to have, we can see here that we have a common term, which is x raised to negative 1y and x raised to negative 1y. So there should be no repeating terms. So this, we're going to have merging C and D. We'll have 2x minus x raised to negative 1y plus y squared over 2, which is our f nu xy. Yan. And of course, step I is to form the general equation or general solution, which is f nu xy equals to c, equal to c. So this will give us 2x minus x raised to negative 1 y plus y squared over 2 equals c. Yan. So there we have it, ladies and gentlemen. Our solution, oops. Yan. Our general solution is 2x minus x raised to negative 1y plus y squared over 2 is equal to c. All right. Now let's move on to our next problem. we have example number 4, 5x plus 3 e to the y dx plus 2x e to the y dy equals to 0. So let's solve this. Solution. We first identify m and n. Okay. And from the equation, we can easily identify that m is 5x plus 3 e to the y, and n, xy, is actually 2x e to the y. Our next step, of course, is test for exactness. And that is by satisfying partial derivative of m with respect to y equals partial derivative of n with respect to x. Taking the partial derivative of m with respect to y is actually the derivative with respect to y of our function, which is 5x plus 3 e to the y. Okay. And the derivative is, since x is, since we're differentiating this with respect to y, we treat x as a constant. So the derivative of a constant is 0 plus 3 e to the y will give us also 3 e to the y because eu du, right? How about the partial derivative of n with respect to x? It is actually the derivative with respect to x of 2x e to the y. So this is, with respect to x, we have 2 e to the y. Now clearly from the two, our conclusion is that they are not exact. And with that, what we must do is to find the integrating factor. Find the integrating factor. Yan. And how do we do that? We first check, no, if epsilon of x, which is the partial derivative of m with respect to y, minus partial derivative of n with respect to x, all over n, is a function that is fully dependent on x. So let's try and do that. We have partial derivative of m with respect to y is actually this one, 3e to the y. Nakuha na natin siya. So 3e to the y minus 2e to the y all over yung n value natin, which is this one, 2x e to the y. 2x e to the y. Simplifying, we'll have 3 minus 2 is e to the y all over 2x e to the y. Clearly, e to the y cancels out. Yan. And we are left with epsilon of x equals 1 over 2x. Now, 1 over 2x is fully or solely dependent on x. So, we can proceed with getting the integrating factor being e, the integral of epsilon of x dx. That is e, the integral of 1 over 2x dx. Or, we have e 1 over 2 integral of dx over x. So moving to the other side, continuing this, will actually give us mu of x equals e raised to 1/2 ln x, because du over u, ln u. Okay. So further, we have by properties of logarithms, e raised to ln square root of x. Okay. So the natural logarithm, if the natural logarithm is raised to e, then that cancels out, and we have mu of x being square root of x. All right. So we now have our integrating factor. Now that we have our integrating factor, we move on to our next step, which is getting our new function of x. And that new function of x is found by multiplying mu of x to the old or the original f. So multiplying, we're gonna have square root of x multiplied to the whole equation, which is 5x plus 3 e to the y, and this is dx plus 2x e to the 4 or e to the y dy. Yan. Equals 0. Yan yung whole equation. Okay. So multiplying, magkakaroon tayo ng 5x raised to 1.5 plus 3 square root of x e to the y dx plus 2x raised to 1.5 e to the y, e to the y dy, of course, equals to 0. Yan. So we can see here that m, or mu, is 5x raised to 1.5 plus 3 square root of x e to the y, and our n nu is xy equals 2x raised to 1.5 e to the y. Yan, e to the y lang. Okay. We identify that because we need to be sure, be very sure, that this is now exact. And we can do that by, once again, doing test for exactness sa ating new function. Taking the partial derivative of m with respect to y. This is actually the derivative with respect to y of yung new natin, which is 5x raised to 1.5 plus 3 square root of x e to the y. Okay. Taking the partial derivative of n with respect to x, which is actually the derivative with respect to x of the new function, which is 2x raised to 1.5 e to the y. This gives us 0 plus plus 3 square root of x EU du, e to the y. Okay. And how about this one? We have power rule, no? So 1.5 times 2 is 3. And then 1.5 minus 1 is raised to 1.5, or 1 half, 0.5 e to the y, which is also equivalent to 3 square root of x e to the y. Ayan. They are now both equal. So our conclusion is that we have verified that this is exact. Yeah, very good. We can now proceed to solving this by exact method. EF. Okay. So F is by exact method 2. I do exact method 2 kasi mas madaling tandaan. And that is taking the integral of ito yung mdx, mxy dx, and then integral of n xy dy. Yan. So the integral of m, yung new m natin actually, no? Ito na lang nailagay yung m. Yung new m natin is this one, 5x 1.5 plus 3 square root of x e raised to y. So let's import that to our m. So this becomes 5x raised to 1.5 plus 3 square root of x e raised to y dx, of course. And then yung n natin is the integral of 2x raised to 1.5 e to the y, of course, dy. So integrating, actually gonna get with respect to x, factoring out 5, we have x 1.5 dx plus 3 e to the y square root of x dx. So this simplifies to 5 raised to 1.5 plus 1 is 2.5, no? X raised to 2.5 all over 2.5. Or further simplifying, simplify ko na, hindi ko na isusulat para retsa na tayo. 2x raised to 2.5 plus 0.5 plus 1 is 1.5. 3 divided by 1.5 is 2. 2 e to the y, or 2 x raised to 1.5 e to the y. Yan. No? Yan. Okay, now moving to n, we're gonna get with respect to y, we can factor out 2x raised to 1.5. Integrating e to the y dy will give us eu du is simply 2x raised to 1.5 e to the y. You can notice that we have a common term, this term, and this term, right? So copying the 2. So step H, and that is merging yung ating G and F kakaroon tayo ng, with no repeating terms, kakaroon tayo ng f nu xy, we have 2x raised to 2.5 plus 2x raised to 1.5 e to the y. All right. And of course, finally, or dito na lang din para mabilis. Siguro step I. Yan, kita pa naman, no? Yan. Of course, form the general solution. We have f nu xy equals to c. Yan. So, magkakaroon tayo ng 2x raised to 2.5 plus 2x raised to 1.5 e to the y equals c. Okay. All right. And there you have it, ladies and gentlemen, our final answer. Oops, sorry about that. Final answer is this one. Okay. 2x raised to 2.5 plus 2x raised to 1.5 e to the y equals c. All right. We move on to our next example, example number 5. We have y dx plus 3 plus 3x minus y dy equal to 0. So solution. So step 1 is to identify m xy and n xy. We have m here to be simply y. Saya. N to be 3 plus 3x minus y. Okay. So, next is to test for exactness. And that is by satisfying the partial derivative of m with respect to y equals partial derivative of n with respect to x. So, partial derivative of m with respect to y gives us the derivative with respect to y of the function y. Dali, di ba? Equals to 1. Partial derivative of n with respect to x actually is the derivative with respect to x of 3 plus 3x minus y. This gives us 0 plus 3 plus 0. Clearly, this is not exact. Okay, not exact. And so, we have to make this exact. How? By, yes, finding the integrating factor. Okay. So, how do we find the integrating factor? We first consider epsilon of x equals partial derivative of m with respect to y minus partial derivative of n with respect to x all over what? All over n. Oops. Yan. And that is, yung partial derivative of m natin is 1. Partial derivative of n natin is 3. All over n is 3 plus 3x minus y. So we have 1 minus 3 all over, oops, all over n, which is 3 plus 3x minus y. What happens? This can be simplified to negative 2 all over 3 plus 3x minus y. Now, is this a function that is solely dependent on x? I think no matter what we do here, we cannot eliminate and or factor out y. So, ibig sabihin, we have to move to case 2. Case 2. And that is psi of y equals the partial derivative of n with respect to x minus partial derivative of m with respect to y all over m. Yan. So, let's try. We have n minus m, so 3 minus 1 all over y. 3 minus 1 all over y. This gives us 2 over y, which is an expression that is solely dependent on y. Yun. So, ibig sabihin, si psi y ang gagamitin natin. And kapag si psi y ang ating function that function that was satisfied, ang gagamitin nating integrating factor ay, of course, c psi y din, which is, c mu of y. Mu of y equals, baba natin kasi baka hindi makita. Mu of y equals e raised to the integral of psi y dy. Yan. So, psi y, as we know it, is 2 over y. So, e raised to the integral of 2 over y dy. This gives us what? Factoring out 2, e raised to the integral of dy over y, which is, as we know it, e raised to 2 ln y. And by property of logarithms, e raised to ln y squared. Finally, when a natural logarithm is raised to e, they cancel out, and we're left with mu of y being y squared. Ayun. Okay. Alright. Now, nakuha na natin yung ating integrating factor, which is y squared. What do we do next? What we do next is we multiply this integrating factor to our new function f. That is f new step D, f new equals mu of y multiplied to the whole non-exact function will give y squared multiplied to y dx plus quantity 3 plus 3x minus y dy equals 0. So that whole equation gives us y cubed dx plus 3y squared plus 3xy squared minus y cubed dy. Yan. Of course, equal to 0. Right. Okay, we now move on to our next step. Kasi, hindi na ako magte-test for exactness, no? Kasi, alam natin exact na siya. No? Tiwala lang, exact yan. But you can actually verify. But for the sake of time, I'm going to jump to the next step, which is integrating by by exact method 2. Actually, you can use any method that you prefer or that you're most comfortable to. I prefer method 2 because it is easier to recall, no? And that is simply by taking the integral of m dx, no? And then of course taking the integral of n dy. Ayan. So, we're going to get the integral of m, yung bagong m natin, which is in this case, ito. Ito yung ating m. And ito naman yung ating n. Alright. So, we have integral of y cubed dx. So, factoring out y cubed dx, magkakaroon tayo ng x y cubed. Of course, disregarding muna yung ating arbitrary constant. And then, dito naman, we'll have integral of 3y squared plus 3xy squared minus y cubed dy. Okay. Will give us, factoring out 3, we have y squared dy plus 3x y dy minus y cubed dy. Will actually give us y cubed plus 1.5. Tama ba? 3x y squared over 2. Tama? This is y squared pala. Yun. So, dapat x y cubed. Yun. X y cubed minus y to the 4 all over 4. Ayan. That is our n. We can call this equation E or equation C, equation D. Kahit ano naman yan, pwede. So, since nakasaynayan natin si equation C, this is equation D. Merging the two. Si C and D. Kakaroon tayo ng we'll notice na meron tayong isang similar term, xy cubed and xy cubed here. So, merging the two, we'll have our new xy to be y cubed plus xy cubed minus y raised to 4 all over 4. And of course, forming the general solution, and that is f nu xy equals to c, no? Yun lang. We'll have y cubed plus xy cubed minus y raised to 4. Pangit ng y ko, no? Y raised to 4 all over 4 equals c. Yan. And that, ladies and gentlemen, is our solution to the non-exact DE. Y cubed plus xy cubed minus y raised to 4 all over 4. All right. Our last problem is example number 6. Solve the DE xy dx plus 2x squared plus 3y squared minus 20 equals 0. Okay, so let's do that. Solution. We have, first, of course, identify yung m xy natin and n xy. Yan. So, m is clearly xy and n is 2x squared plus 3y squared minus 20. Yan. Now we move on to our next is we need to be pretty sure if this is exact or not. No. So we move to our test for exactness by satisfying the partial derivative of m with respect to y, partial derivative of n with respect to x. Yan. So, taking the partial derivative with respect to y of m is actually the derivative with respect to y of xy. Simply x. But for the other component, we have minus 20. We're going to have 4x plus 0 minus 0. Okay. Now, from the two, our conclusion is that they are not exact. And when they are not exact, what do we do? We will do everything for love. I will do everything for love. Yon. No. So, we find the integrating factor. Ito yung sangkap na bubuo para maging sakto ang hindi sakto. So, see? Find the integrating factor. And we'll be able to do that by first considering, of course, considering epsilon of x. And that is the partial derivative of m with respect to y minus partial derivative of n with respect to x. This is all over m. Okay? So let's substitute that. Nakuha na natin si partial derivative of m and si partial derivative of n. So plug and play all over n. Sorry, this should be n, not m. Letter n. Yan. So, meron tayong x minus 4x all over, what is our n? 2x squared plus 3y squared minus 20. So, looking at it, mukhang mahihirapan tayong tanggalin tong si y squared dito. From the looks of it, this is not solely dependent on x. So, we move on to our next criteria. Kasi yun naman ang ginagawa, di ba? Kailangan mag-move on. Yes. And we move on by considering psi of y. And yung psi of y natin is the partial derivative of n with respect to x minus partial derivative of m with respect to y all over m. Okay. Saan nga galing itong mga to? Yun yung dinerive natin kanina, di ba? Yun yung partial differential equation na meron tayo. And then we considered simplifications, no? Kaya meron tayong case 1, which is si epsilon, and si case 2, which is si psi. So, n minus m is 4x minus x. 4x minus x all over m, which is xy. Nako, ito mukhang may pag-asa to. Kasi 3x over x, y, cancels x. We're left with 3 over y. So, psi of y pala ang ating gagamitin. Si psi of y ang gagamitin natin. Interesting, right? So, psi of y. Now that we have sine of y, what do? We actually solve for the integrating factor mu of y, because mu of y is e to the integral of, okay, psi y yan yung parang tinidor ni Satanas, no? Yung psi. Kaya ingat kayo sa mga psi. Psi y. Wala, sobrang unrelated, no? Sige, last ko na po yun. Integral of psi y dy equals, hirap kasi wala akong kausap eh, di ba? E raised to integral of, ayan, 3 over y. Okay, dy. So, expanding this further will give us, sayang yung space. Sige, dito na lang. E raised to the integral of, factor out natin si 3, meron na naman tayong uling dy over y. Sensya na, pangit ng y ko po. So, obviously, this becomes e raised to 3 ln y, which in terms by properties of logarithm becomes e raised to ln y cubed. And since a natural logarithm is raised to e, our mu of y is y cubed. Alright. Okay. So, yan. Y cubed. Now that we have an integrating factor of y cubed, hindi masaya pagka mag-isa lang siya. Kailangan natin siyang pahayuin at magpakarami. And that is by forming a new function. Anong step na ba to? D ata. Ano? Hindi nga ba? Hirap nitong, yan, tama. Itong setup natin, no? D. Okay. So, D, we have, what do you call this? The new function xy. Yan. And that is multiplying yung ating integrating factor to our fxy. Yan. Okay. So, doing just that, we'll have, ano nga uli yung integrating factor natin? Y cubed. Yung nasa baba. So, we have y cubed multiplied to yung ating original given problem, which is xy dx plus 2x squared plus 3y squared minus 20 dy equals 0. Ayun. So, ano mangyayari? This will become x y to the 4th dx plus 2x squared y cubed plus 3y raised to 5 minus 20y cubed dy equals 0. Yan na yung ating new. This is our new. So moving on to our next step, we have, of course, by exact method 2, again ako, kasi favorite ko siya. Dito na lang tayo sa next, no? Hindi, sige. Tignan nga. Dito na. Hindi, sige. Sayang. Sorry. By exact method 2. We're gonna do the integral of m xy. Of course, yun yung new. Okay. dx, mdx, and then integral of n xy dy. So, rekta na natin. Magkakaroon tayo ng integral of y to the fourth x dx, and that is equal to x squared y to the 4 all over 2. How about this one? The integral of, we're integrating with respect to y. So, pwede natin i-factor out si 2x squared y cubed dy plus 3 y raised to 5 dy minus 20 y cubed dy. This will give us y to the fourth, no? So 1/2 or x squared y to the fourth all over 2 plus 1/2 y to the 6 over 2. Tama? Mali. Kasi dapat y to the 6 all over, tama. Y plus 5 plus 1 over 6. 3 over 6 is yeah, 2. So y to the 6 over 2 minus 20 divided by 4 is 5. 5 y raised to 4. Ayan. 5 y raised to 4. We can notice before we proceed to our next step, which is merging, no? That meron tayong parehas na term dito. Ito at ito. Right? So our final step is to merge second to the last. Merge yung E and F. So magkakaroon tayo ng, and set this to F new. So our F new x of y is x squared y to the fourth all over 2 plus y to the 6 all over 2 minus 5y raised to 4. So finally, forming our general solution, we're gonna have and that is, of course, f of f new equals c. So this gives us x squared y to the fourth all over 2 plus y raised to 6 all over 2 minus 5y raised to 4 equals c. And there we have it, ladies and gentlemen, our final answer for example number 6. Okay, x squared y to the fourth over 2 plus y raised to 6 all over 2 minus 5y raised to 4 equals c. All right. So that is our solution for our differential equation for example number 6. And that ends my presentation for problem set number 6. This is our problem set. 5 items again. Solve the following DE. And as Lasalians, let us pray. I will continue, O my God, to do all my actions for the love of thee. Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. Thanks, guys, and hope to see you again in the next lesson. Bye and God bless.